started another. Okay, so the differential of this function will be then 10 t to the fourth multiplied by dt. So if I have an integral in t, when I change it into an integral in u in this case, because we use the notation u, everything must go, meaning wherever, when I copy the new integral, I create a new integral, it can no longer have t in it. So this piece is obviously u to the 10th. Now, this is already replaced. But what about t to the 4th times t? I have it right here. It's du over 10. It's a constant. It's 1 over 10. It can go outside. U to the 10th du. This is so much easier to handle than this. And it's the same thing. So then the answer is 1 over 10 u to the 11th over 11 plus a constant c, or 1 over 110. Now I have to go back to the original variable. Now I have to replace at the very last step, I have to replace u by what I used to denote 2 power 11 plus a constant c. And you can say, show me that it works. So this is okay. Yes. If I differentiate this, I have to get this. It's guaranteed to get this. 2t to the 5th minus 3 to the 10th, t to the 4th. And now I would like to go back to this. So if I have y equals e to negative x, and I'm asked to find the average of this function on 0, 1, I know it's 1 over 1 minus 0, but it's 1, so I don't have to write it. From 0 to 1, from e to negative x dx. But now, I realize that I have to use a notation, let's say t equals negative x. Because I don't know what a antiderivative is. I do, by practice. But I want to show you why it is what it is. And moving forward for this function, we can remember the antiderivative. Okay, so I denote this by t. And now this is a function. I have to find its differential. dt equals negative 1 dx. So another way of addressing this is I'm multiplying by negative 1 twice. Negative 1 times negative 1 is 1. I didn't change the problem. But negative 1 with dx is this. Negative 1 and dx will be replaced by dt. So this is negative, the integral from 0 to 1, from e to t dt. Notice that this is a definite integral, and what we looked at was an indefinite integral, which was the answer was a function. And now here we expect a number, because it's a definite integral. That doesn't change. Which function prime is e to the x? That's not a big deal. It's the same thing. It's the same thing. It's the only function. Known function. There are other functions which have the derivative themselves. But this is a well-known function. Okay, so then I plug in 1 and I get e, minus when I plug in 0 and I get 1. So the answer is negative e plus 1. I jumped into a conclusion too soon. When we change the limits, when we change the function for a definite integral, I have to change the limits of integration. It happened that this is okay when x is 0, t starts at 0 as well, but when x is 1, this is negative 1. So when I plug in -1, I get 1 over e. And when I plug in 0, it's okay. So this is 1 over e minus plus 1. So I'm going to write it again because it's not clear. -1 over e plus 1. And I'm going to erase that one. So that was not necessary for indefinite integrals because we don't have limits of integration. But here we have to. In your book, which I don't recommend, but it's up to you and I accept it. I just don't recommend it. What they do is they change it into an indefinite integral. They calculate everything with the indefinite integral, and then they go back, like we did here, back to the original variable. I don't recommend it. There is no need. There is no need simply because the answer is a number. So why would I go back? I already changed the limits of integration because I cannot write this as this. They're not equal. When x is 0, t is 0. When x is 1, t goes to -1. Yes, you could change this if you'd like, but it doesn't matter. It's the same thing. It's still from 0 to -1, e to t. When I plug in -1, I get 1 over e, and when I plug in 0, I get 1. And this is the final answer. That's the difference between the substitution rule for indefinite and the substitution rule for definite. I would not recommend you go back to the previous notation or the previous function in determining definite integrals with the substitution rule. And now basically we can choose anything you want from 1 through 60. Choose whatever you want. That's all I had to say basically in this chapter. And now I would like to practice. We still have about 10 minutes or so. I'd like to practice as many as you want.
Okay.
Again, 421, 422. Any problem? Some are more time consuming than others, but they're all the same thing. And this will be the end of chapter 4. $42 it is. Okay, let me see. 42. Where are you? 42. I see it. So it's the integral from. It's still indefinite, and I'd like to choose a definite after that. You choose 5x, and I think the power, I see it as being 6. Am I correct? No, it's 4. Is it 4?
Yeah, I see 4.
Okay, me too. Good. Perfect. Okay, what bothers me here, so to speak, is this quantity. Why does this quantity bother me? Because the square root or any root from a minus b cannot be simplified. This does not equal the square root of a minus the square root of b. So there is nothing I can do to it unless this changes into one term. So I'm going to say let any letter you want, let's say y, equals 1 minus x squared. Remember, I need dy, which is -2x dx. If I don't get this, I cannot move from, or I cannot change this integral into an integral with u, in u, only in u. I cannot have both x and u anymore. I mean, when I move to, or I change it into the new integral, it has to be only y. The integral from. This is the easy part, because it's y to 1/4. So this is done. The 5 will go in front. And now let's see what is left. X is left and dx is left. But it's okay. I have x and dx. That will be dy over -2. So -1/2 dy. Should I repeat this before I continue? So let me say it one more time. So we decided to denote 1 minus x squared by y. So dy equals -2x dx. I have to determine dy because otherwise I cannot create an integral without dy. So I cannot leave anything behind. Everything has to be accounted for, and I have to move from x completely to y. The 5 goes in front. It's a constant. The fourth root of y is y to 1/4. This is y to 1/4. And now I have left an x and a dx. But I know that x and dx are nothing else but dy over -2. So I put a -1/2 and times dy. dy has to be at the end. I cannot put it in the middle. I take -1/2 in front. So I have -5/2. The integral from y to 1/4 dy. Much more human than what I had before. I didn't even know what to do with all this. But now I will say -5/2 y to 1/4 plus 1 over 1/4 plus 1 plus a constant c. I know that this must be a function. It's an indefinite integral. So 1/4 plus 1 is 5/4, and I flip that. So -5/2, 4/5 times y to power 5/4 plus a constant c. Since this is an indefinite integral, I have to replace y. I have to go back to this. I simplify. So this is -2. The fourth root of 1 minus x squared to the 5th power plus a constant c. Very good pick. Thank you. I appreciate that. Let's pick also a definite integral. Those are in the next set, 43 through 60. Any problem before we adjourn today so we can look at another definite integral with the substitution? Would you like to choose, or I will? I would like to choose 58 unless you have something else in mind, or 50. Anyone? Anyone? Any preference? Okay. Yes, go ahead.
I was gonna say, can you do number 58?
58 it is. Good. (58) I see the integral from -1 to 0, correct me if I'm wrong, x cubed dx divided by, I see 2 minus x to the 4th raised to power 7. Am I correct?
Yeah.
Okay, very good. And you know what bothers me, right? I'm sure you do. This bothers me in the denominator. So I'm going to say let u, for example, be 2 minus x to the 4th. If I don't have du immediately, then I will be in trouble because I cannot change the integral into an integral in u if I don't have du. I don't want to forget, I have to plug in -1. So the lower limit is -1, but for x. So when x is -1, -1 to the 4th is 1, 2 minus 1 is 1. That makes it a lower limit for u. When I plug in 0, then I get the upper limit for u, which will be 2. Next, the denominator is nice. Why? It's u to the 7th. Now, what do I have at the top? At the top, I have this. I have x cubed dx, which will be nothing else but du over -4. So I'm going to put du here and 1 over -4, which will go in front anyway. The integral from u to -7 du from 1 to 2. There is no need to go back to the limit, to the variable x, because this is a number. So -1/4 u to -7 plus 1 over that number from 1 to 2. So in front I have 1/24. I plug in 2. I get 1/2 to the 6th. When I plug in 1, I get -1. Okay, 2 to the 5th is 32. This is 64. So 1/24, 1/64, and -1. Any questions? Any questions so far? Okay, let's finish it up then. 1/24, the least common denominator is 64. 1 minus 64 is -63. So this will be -63. And lazy people calculate 24 multiply by 64 with a calculator, 1536. Yeah, I can simplify by 3. -21 and divide this by 3, and I get 512. Any questions? Any questions?